Okay, guys, we are going to go into how to find the probability distribution for a sample. You should know up to this point that we have this normal calculator. We go to Stat, Calculators, Normal, and that gives us this thing right here that you see. So what's going to end up happening is we're going to talk about how you enter the information and what you should be getting. So right off the bat, we have a population mean of 50. So your population mean is the mean you're comparing everything to. So the population of 50, the mean should go right there. The standard deviation is 10. So I'm going to put a 10 right there. And then what's the probability of, like, I have a sample mean right here. So I have a sample mean of 48. So what's the chances of finding one person that is 48 or lower? So that value comes out to be about a 42% chance of that occurring based on a population mean of 50, a population standard deviation of 10, and a single person or one person being below 48. We can also do above 48, and there's your numbers there. So what happens when we ask more than one person? Well, we have to do the basically what's called standard error of the mean, and we have to divide by the square root of the sample size. So when I had one person, the square root of 1 was 1, and 10 divided by 1 is just 10. So with one person, nothing was different. But when I have two people right here, or excuse me, 4 people, I need to divide by the square root of 4, which is 2. So that changes my standard deviation to something called the standard error of the mean. So 10 divided by 2 is 5, or also known as 10 divided by the square root of 4. So the thing is I need to convert. I need to change this standard deviation. I cannot use just 10. I have to use 10 divided by 2, which is 5. So if I plug in a 5, there's my chances of a population mean of 50 with a sample size of 4 and a population standard deviation of 10. So I'm going to combine this 4 and this 10. So 10 divided by the square root of 4 is 5. And so the chances of me finding a collection of 4 people whose average is less than 48 is 34.45. So I'm going to put this right here, 0.3445. That's basically my answer. Okay. Now watch this. I can also do this. My standard deviation of the population is 10, and I can hit divide by square root, SQRT, of 4, because I have a sample size of 4. I hit enter, 34.45. Same exact number, same exact value of what I'm getting. Okay, so I can actually just hit 10 divided by the square root of 4. So instead of having to do this math right here, saying what's the square root of 4, take that number, plug it in here, then take that number and divide it, I can literally just hit the square root of 4. Same thing here. What if I ask 16 people? The square root of 16 is 4. 10 divided by 4 is 2.5. So let me type in 2.5. 2118. So I'm going to type in 0.2118. But I could also just simply take the population standard deviation divided by the square root of 16, and I get 2118. Same exact value. So on your sample size, you can literally just go through and just take in and divide by your square root of your sample size. So I'm not even going to bother with the next one in terms of the longhand. I'm just going to say what's this square root. So what's 10? The population standard deviation is 10. So what's 10 divided by the square root of the sample size, which is 25, and I'm going to get 1586. And if I had 100 people, I could type in that. If I had 1,000 people, I could type in that. If I had, say, 87 people, I could type in that. And all I have to do is I have to take into account how many people are in my sample size, and that's what I'm using for the square root. Okay? And I can just type it in directly. And so this answer right here is saying there's about a 3% chance that I can find a group of 87 people whose average collectively is less than 48. So that might be the simplest and most direct forward approach you can do. You just take your, right here, you just take your population standard deviation, you divide it by the square root of your sample size, whatever that might be. You hit enter, and it will give you the probability distribution this way or this way, depending on what you need. So I hope that helps clear things up. This is a video you can go back to often as you need it.